Jan-based training. Learn and grow.
First of all, we'll understand what is software testing. Okay, and you'll see that under software testing there are different definitions of software testing. It's not that there is one normal or common definition through which you can define software testing. uh, there are various available definitions for software testing from organization to organization. Okay, so we'll learn about them, but the core objective of all the software testing is going to be same, and we'll learn about those objectives of software testing definitions as well. Then we are going to learn about why do we test softwares, what exactly is the need for testing a software, and we'll also see some historical events where the software testing was not taken too seriously and it has some adverse effect. Okay, then we are going to understand what are errors, faults, and failures, and then we'll understand about principles of software testing. So there are 7 principles of software testing. We'll understand them in detail, and we'll understand that what those 7 principles of software testing is trying to convey to us. Okay, and finally we'll understand about fundamental test processes. Okay, so that's it that we have got for today's session. We'll try to cover most of them. Okay. Now let's go to the first slide. Okay, so it says what is software testing. Okay, now if I'm going to read this, so it says that software testing is an activity in software development. Okay, now always remember this, there is a word called software development life cycle. Okay, software development life cycle. Now this software development life cycle, and we'll study this in detail in upcoming sessions, but just to give you an overview, so every software has to go through this software development life cycle, and the software development life cycle has different phases. Okay, it has different phases. So for example, there is the first phase is your requirement analysis phase, the second one is your feasibility study phase, the third one is your design phase, the fourth one is your uh, development phase or coding phase, fifth one is your testing phase, then it is deployment phase, and finally maintenance phase. So these are different phases of software development life cycle. Out of those phases, one of the phases, as I've told you, is a testing phase. Okay, in that entire software development life cycle there are different phases, and one of the phases your testing phase, and we are just going to study about that phase only. Okay, so that's the reason it says that software testing is an activity in software development. That means software development phase, software development life cycle phase. Okay, so it's one of the phases of software development life cycle, or it's one of the activities in the entire software development life cycle phase. Okay, so it is an investigation performed against a software to provide information about the quality of the software to the stakeholders. That means we do some kind of investigation to ensure that the quality of the product is fine. It is in accordance with the expectations that was set for it. Okay, whatever requirement was given to us, those requirements are being fulfilled by our software. So in order to ensure that those requirements are being fulfilled by our software, we do a kind of investigation. Okay, that everything is working fine, all is well. Okay, so that is what is software testing. Now you see it says that different people have come up with various definitions of software. Okay, so if I just go to the next slide and then I'll come back to this. So there are various definitions for software testing. Okay, see, different organization, different people have given different definition. Someone says that testing is a process of establishing confidence that a program or system does what it is supposed to do. Okay, so once you have tested your application, once you have tested your product, it gives you a confidence to say that what you were expecting out of this program, or what you were expecting out of this product, or what you were expecting out of this software, it is actually doing that. Okay, so that is one definition by one definition of software testing. The other definition of software testing says testing is a process of executing a program or a system with the intent of finding errors. Okay, that is another very interesting thing. So as a tester, your first objective should always be that I want to break this application. Okay, So as a tester, that should be your mindset. Okay, it's as a tester, it's your job to break the myth that everything is working fine in the software. Okay, so uh, that should be your intent. Okay, so it says that testing is a process of executing a program or a system with the intent of finding errors. So this is how you should uh, be always looking out for. Okay, then there are a few definitions like software testing is a process of exercising or evaluating a system by manual or automatic means to verify that it satisfies a specified requirement, to identify difference between actual and expected result. Okay, so this is another definition. Once we have learned about how to create test cases, then this definition will start making more sense. So in test cases, we write actual result and expected result, and we try to ensure that the actual result is same as expected result. So if actual result is same as expected result, so that means the software is working fine. So we'll learn about this definition in detail. And similarly, there are other definitions as well. But the common objective of all the definition, or the common objective of all the testing that we perform, will be this. So if I can go to the third slide again. So we don't have to be very much concerned about the definition of software testing. You can have your own definition, you have your own experience, and based on that you can have your own definition. But the objective of all the software testing has to be same. And what are those objectives? The first one is to ensure that the software meets the agreed requirement and design. That should be the first objective of your testing. Okay, that whatever requirement is given to us by the client, that requirement is being fulfilled. Okay, the application is working as per the expectations and in accordance with the agreed requirement. Okay, we'll see all these things in actual execution. Okay, and then we'll talk about it, that if this is what the requirement was, and are we actually fulfilling this requirement or not. Okay, so but the first objective of software testing is to ensure that the software meets the agreed requirements and design. Okay, the second thing is the application works as expected. Okay, so if you have designed a login page, so that means every time I enter my correct username and correct password and I click on login button, I should be able to successfully log in into my application. Okay, so the application works as expected in this particular scenario. So that should be our second objective, that whatever agreed requirement was given, our software is fulfilling those requirements, and second, it is working as per the expectations. Okay, now the third thing, it says that the third objective is the application doesn't contain serious bugs. Now that is very interesting question. It could have also been written as the application doesn't contain bugs, but it has written the application doesn't contain serious bugs. And the reason it is written, it has been written this way, why we are focusing more on serious bugs, because it is a common understanding. And this was, while you are working in an IT field, while you are testing in any application, you will realize this, and some of you have worked it, so they'll agree to this, that you cannot ensure 100% that you cannot ensure that an application is 100% bug free. How I am going to test an application will differ from how you are going to test an application. So every pair of eyes will look at an application differently. Every brain is going to investigate that application differently. Okay, so we never say that the application is 100% bug free. And I'll show you with some examples that uh, uh, where you'll realize that you'll think that you have almost come up with all the bugs that were there within the system, but we always leave something here and there, maybe not functionally, but maybe some cosmetic errors might be there which we may not have seen, or maybe there are other some feature or functionalities issues. So the objective is that your application might have some trivial bugs or minor bugs, but there should not be any serious bugs. And we'll also see what do we mean by serious bugs. Once we study about severity and priority, we'll understand what exactly is serious bug. And the last thing, meets is its intended use as per the user expectation, which is quite similar to the second one. So the application is working as expected, and then there are, it's whoever is going to use that application, it's also working as per the user expectation. So what exactly that means is, your application should be user friendly. If your application is not user friendly, even if it's a good application, it's capturing so different features and functionalities, still if it is not user friendly, nobody is going to use it. Okay. And if you remember, there was a social networking site Orkut that was very famous. It was designed and developed by Google. It was very famous, but it was not that user friendly. Okay. Then came Facebook. Facebook was user friendly. It was the design was exceptionally good when you compare it with Orkut. The finishing was just great. It was very user friendly. It has few more features and functionalities when you compare it with Orkut. And as a result, despite Orkut being promoted by such a big firm, Google, it didn't work. It failed to uh, a 2-3 person who were involved in developing a normal social networking site website. They don't have that much, finance. They don't have that much of expertise, but still they were successfully able to dominate Orkut in social networking area. So the reason is, Orkut was not that user friendly. It has got everything. It has got huge marketing support. It has got huge financial backup. It has got, such a big team, so many minds, working on it. But the major reason for its failure was why it lost to Facebook is that it was less user friendly when you compare it with Facebook. Okay, so these all are the four objectives of software testing that you need to remember. The first one is, whatever requirement is given, whatever design is given, that is being captured in our software. Then functionality wise, this is working fine. Then it does not contain any serious bug. It may contain some minor or trivial bugs, but it shouldn't be containing any serious bugs. And we'll see what exactly we mean by serious bugs in upcoming sessions. And then it should be user friendly. Your application, you have to test your application thinking yourself as an end user. So even if the application is working fine, for example, if I can show you something, let's say, let me open a print over here so that I can show you what do I mean by user friendly. So let's say that, there is a form, and this form comprises of, let's say, few fields like, this is your username field, and then this is your password. Okay, so let me write it out here. Let's say this is your login page. So here I'm writing it username, and here I'm writing password. And then here I'm writing a, let's say I'm writing a button over here. I've created a button over here, and I'm going to call this button as login button. Okay. Now, if you see this, this is just a general form. If you see this form, so it has got a username field and a password field. Now, functionally, this might work. I mean, if I enter my username and password and click on login button, I'll be able to log in into my application. But this is not a user-friendly application. I mean, you don't see login button at the top of the page, right? So even if the requirement is fulfilled, the requirement said that my login page should have username, password, and login button. So with that respect, your first objective is fulfilled. Okay. So as far as login page was concerned, they told us the requirement says that it should have username, password, and a login button. So the first requirement is fulfilled. The second requirement says that the application works as expected. So the expectation was that every time I provide correct username and password and click on login button, I should be able to log in into the application, which is happening, right? When the second is working fine. The third says the application doesn't contain any serious bugs. So let's assume that it does not have any bug as of now, any serious bug as of now. But is it user friendly? So it's not user friendly, right? Login button, I mean, ideally we look out for login button at the bottom of the page, but here it is at the top of the page. Or there could be, another design like it could be like here, and then I can have some use one text box over here, one text box over here, and then I can have, let's say, login button over here. Write it. So this is your username. Let's make this as password. Let's make this username. This login button. Okay. Now, if you look at it, even in this form is fulfilling all the things. It is fulfilling all the requirement of username and password and login button. And then, it is also doing what it is expected to do. So if you enter correct password and correct username and click on login button, we'll be able to successfully log in into the application. But is this user friendly? This is not user friendly. We are giving password first and then username. So this is now not a user friendly application. So is the case with this particular login page. So we have to ensure that all these four objectives, every time you test your application, just try to check that all these four objectives are being fulfilled. So we have understood what are different definitions of software testing and what exactly is the objective of what exactly should be your objective of software testing. Okay. So this is about software testing definition and its objective. Now the next question that comes to our mind is, why do we test software? So in a way, if we just focus on the objectives of software testing, so somewhere that altogether gives you the answer that why do we need to test the software. But before that, I need to tell you sometimes when the application was not tested thoroughly, or the application was not taken that seriously. So what were its side effects and how it started affecting the day-to-day life of people? Okay, so how many of you are aware of Y2K bug? Have you ever heard of this Y2K bug? This was very famous, yes, in 2000. Okay, so Y2K bug. And let me introduce you all people what this Y2K bug was. Okay, and what exactly was problem with this. Okay, so what happened that in the last century, the software developers had never thought that their code and creations would survive into the new millennium. This is something that happened around 2000. Okay, for this reason, actually, the dates that were used in our computers before 2000 was like, let's say if I have today's, I have to write 22nd May. So it would be like 22nd May, that is 05, something like this. And then it's 2020. So they would just write this 20. Okay. Now let's think of the time before 2000. I mean 1999, 1998. So from 1901 till 1999. Let's just think of this. So this date would mean during that time as 22nd May 1920. Okay, if they have written it this way, it would mean 22nd May 1920. Okay, similarly, if I have written something like 22 12 like this. Okay, so this would ideally mean 22 December 1991. So they have designed it in such a way that the dates were being read in this way. Okay, similarly, if I have written like 22, let's say 12 10, okay, or let's say 15. So this would be 22 December 1915. Okay, so the programmers at that point of time felt that it's no need, since we are in the 19th century, so it's no need to write 19 over here. I mean, that would capture just additional memory in our system, and this is going to be redundant. And testing was not at that advanced level at that point of time. It was ideally this incident that brought testing in our mainstream. So what exactly happened? This worked fine. I mean, till date like if I go to like 12 12 95. So it was like 12 December 95. Then it was the date changed to 96, then 97, then 98, and till 99 everything was fine. Okay, now the next date that would change would be 00, and now our computer system will treat this as 1900. Now just imagine you have a bank account, okay, and in your bank account in year 1999 you have got like $20,000. Okay, and now my system is going to, with the change of date, this is going to be 00. Okay, so now my system will treat this as 1900, that means the beginning of century, and now your amount would be shown as $0. Can you see the problem? Because the programmers didn't feel that, you know, writing 19 before year was important, and because of this, you know, there was huge financial losses that happened across the globe. So most of, you know, so much amount was invested in order to upgrade the system at the very last moment to avoid some major disaster. But still, you know, uh, some issues, some financial transaction failed, some, you know, financial disparities happened across the globe. Okay, because the application was not tested properly, tested in a way that they never thought of, you know, the future scope of the software. So while you are testing the application, it's not that you have to think of the application in the present mode. You have to always think of the situations your software will go in near future. Okay, so later on, instead of writing this 2-digit number, they upgraded it and they introduced, programmed it so that it always has this, you know, 4-digit year. Okay, so now if you see, you'll see this 2020. Okay, so it means that this is year 2020, the year 1920, and so on. This is 2120. So going forward, this, now this Y2K bug was handled in this way. Earlier it was with 2-digit only, which confused that which century date this is referring to. But now we have this 2020. So this is how it works. Okay, so if you I mean, if you have seen some computer around 80s, if you just Google it out, so you won't be seeing the date as this. It would be shown in the 2-digit format only, and that was done just to save some memory space. Okay, so these are some of the reasons that why do we need to test our software. So had this software, you know, they would have given the requirement that, okay, this computer is going to be used for rest of the time since the, you know, this world is surviving, so they should have tested it with that intention, but they just focused on that particular 19th century, and as a result this bug remained and it caused huge financial losses across the globe. Okay, that was just one example that why actually we need to do a software testing. Okay, now let's just read this definition. So it says that software testing is necessary because we all make mistakes. Some of those mistakes are unimportant, which is obvious, but some of them are expensive or dangerous, as is the case with Y2K. Okay, we need to check everything and anything we produce because things can always go wrong. Humans make mistakes all the time. So that's a general thing. Now, software testing is very important because of the following reasons. So the first reason is software testing is really required to point out the defects and errors that we made during the development phases. Okay. So as I have already told that as a software tester, your objective should be that I'm going to break this application. Okay, I'm going to break this myth that everything is working fine in this application. The more you find bugs, the better QA you are. Okay, okay. The more you find bugs, the better QA you are, and you know, more number of bugs means that you are better aware of your software. You are better aware of the requirements. Okay, so it conveys a whole lot of things. Fine. The next thing is, it is important. So the first thing is, you know, you should be always able to point out defects. And how am I going to point out defects? That's a very interesting question. You know, you're given a software and you're asked to test it. So you know that your objective is to find bugs into this. So the more you are aware of the requirements of an application, the better you are aware of the requirements of an application, you'll be able to identify defects in a better way. You'll be able to identify more number of defects. You'll be able to identify better defects. Okay, so always focus on learning the requirements of the application before jumping to actual testing. Just have a pictorial representation of software. Just have the maybe animation of how the software is going to, what exactly is going to be the business flow of the software in your mind. When you are able to connect all those dots, only then jump for testing. Okay, so once you're clear about the requirements, you'll be able to identify defects and errors in an easier way and in a better way. Okay, the second thing, it says why it is important to test the software. It is important to ensure the quality of the product. Okay, so if you have not tested your application and your application has defects or bug, and it is not doing what it is supposed to do, you are not delivering a quality product. Okay, so it says that it is important to ensure that the quality of the product. Quality product delivered to the customer helps in gaining their confidence, reliability, satisfaction, and business. You'll always see that in software field, it's a client who has been given a good quality product. He's the one who helps you in bringing more business. Okay, so that's the reason why we need to ensure quality of the product. Okay, the first one is to remove all the defects and errors. The second one is to ensure that your product is a quality product and it is bug free. Okay, in order to gain the confidence, reliability, satisfaction, and business from the client. Okay. The next thing is testing is necessary in order to provide the facilities to the customers, like the delivery of high quality product or software application which requires lower maintenance cost and hence results into more accurate, consistent, and reliable result. So definitely, as I've told you, that you have to test your software in such a way that whatever is the expected result, it is accurate, consistent, and the customer can rely on that result. And we'll see all these things while we are actually looking into real application, that how these all things are going to happen. Okay, now the next thing is testing is required for an effective performance of software application and product, which is again true. So you have to ensure that your software is working effectively, and then it is important to ensure that the application should not result into any failures, because it can be very expensive in future or later stages of development. So again, your application should not contain any serious bug. That is why we should test the software. Now let me just show you a simple example. So let me just remove all of these. Okay, now let's say I'm going to design a page and I'm going to write login, and then here I'm going to define another button. Okay, so this is your login button and this is your cancel button. Fine. Now let's say this is your web page. The moment you enter some URL, this is the first page that appears on your screen. Username, password, login, and cancel button. Okay, let's say this is the requirement that is given to you by the client. The client says that the moment I enter my URL, I should be able to see my login page. Okay, and my login page should contain username, password, login, and cancel field. Okay, this is the requirement that has been given by the client. Now we'll think how to test this. It's a simple form, right? How to test this form as a tester and as a quality analyst. Okay, you have to think, how am I going to test this as a tester and as a quality analyst. As a tester, I'll go with the requirement. So the requirement says that it should contain username, password, login, and cancel button. So yes, this is containing all those things. Then maybe I'll check the functionality. I'll enter correct username, correct password, and click on login button, and I'll be able to redirect to my home page or dashboard. I'm successfully able to log in. So functionality wise, this is also working fine. This is user friendly. Yes, this is user friendly. I find username, password, login, all of them placed at correct places. So as a tester, you think that whatever requirement was given to us is being fulfilled in our software. But develop this habit of thinking as a quality analyst and not as a tester. Okay, as a quality analyst, there are various bugs in this application that you need to convey to your client. You know, your client may not be a technical person. He may not be very well. He has a product and he wants a software, to increase his business for his product, and that's the reason he has given this project to your firm to develop in order to increase his business many folds. But as a quality assurance now, while testing the application, you are the person who needs to tell him that uh, there are things that are missing, or there are things that are there on your software that should not actually be there. Okay, so now let's think of this as a quality analyst, and let's try to find out, is there any bug in this design? So all of you have seen login page. Can you find any bug in this design? Just think of all the login pages you have seen in your life. Take
Forgot,
yes,
forgot username, forgot user password.
yes, interesting, very good. So it says that it's missing out something like forget username or password link. Right? Let's say tomorrow I visit this page and I'm not able to log in. I have forgotten my username or password. So how am I going to retrieve this? This is the very first page. I can't get into the application, right? So in a way you will be blocked, right? So you're missing on a major requirement. Forget username and forget password link. It should be there. So you need to tell your client, as a quality analyst, it's your job. This is a bug in your software, right? If somebody forgets his username and password, he or she won't be able to log in into the application. He won't be able to get into the application. So whatever information he has stored in that application, let's say this is a uh, banking application, so you won't be able to do any transaction. You won't be able to see your account. You won't be able to see your savings. You won't be able to do anything, right? So this is one of the major bug, major missing in your software. So as a quality analyst, you are going to raise this. Okay, okay, so this was one of the bugs. Now again, think of all the application login pages you have seen. Do you find any more thing missing over here, or is there something that shouldn't be here but it is there? Anything? Just
Register link
which link?
or register. Like,
Yes,
can you put sign up
yes,
for?
yes. There should also be a sign up link, because only then we'll be able to generate our. So there should be a registration link. Then somebody has dropped me some message. Sign up for an account. Yes. Okay. We have got. Now again, there is something. There are still more bugs. There's still more bug in this. A simple page. It's just a simple login page that we have seen all our lives. We have identified 2 bugs, but still there is something, some more bug into this. There is something that shouldn't be there. Just to hint you all. Okay.
A log out button.
Cancel button. Very good, Bianca. Very good. So how many of you have seen cancel button on login page? You'll never find a cancel button on a login page. Okay. And especially on the very first page of the application, because there is a logic behind using cancel button, and I'll tell you. So this cancel button shouldn't be here, and I'll tell you why. And if you just go through all the pages, you'll never find a cancel button on a login page, and especially if this page is the first page of your application. Cancel button shouldn't be here. Now we'll see why cancel button shouldn't be here. Now there is a logic behind cancel button. Cancel button, every time you see a cancel button, the objective of cancel button is that if I click on cancel button, it should always redirect to the previous page. Okay, that means let's say we have an application which has got page A, page B, and page C. Okay, this is your, let's call this page A, page B, and page C. Always remember, let's say this is the first page. You click on page A, there are some link. You click on link and it goes to page B. There is some link on page B. You click on that link and you go to page C. Okay. Now there is a rule for using cancel button. You can never have cancel button on page A. You can have it either on page B or page C. You can never have any cancel button on the very opening page of your application. And this is a rule that you should always remember, because this is how you're going to, this is going to help you in your testing. So everything that you see on your web page has an objective, has a functionality, has a rule to use. So the rule for using cancel button is you can never have a cancel button on the very opening page. And just Google out any page around the globe. You won't find a cancel button on the very first page. The moment you type the URL, see that page, you will never ever get a cancel button. The reason is, the rule for using cancel button is that if, let's say if I have a cancel button on page B here, okay, or here on page C. So if I click on cancel button here on page C, it should get redirected to page B. If I click on cancel button on page C, it should get to the previous page or previous state. Okay. So if I click on cancel button on page C, it will move to page B. If I click on cancel button on page B, it will move to page A. But if I'm providing a cancel button on page A, it won't go to some previous page because this is the very first page. So that's the rule for using the cancel button. It should always go to the previous. So here in this login page, since I have told you that this is the very first page of the application. So if I'm going to click on cancel button, it won't be having any other page to fall back, because this is the very first page of your application. So this was another bug in our software. Okay. So we just saw that this is a very simple application. I mean, all of us have seen this application throughout our lives. Okay. But still we were able to find some important issues in this. Okay. So that's the reason why we need to test the application, and always try to develop this habit of thinking as a quality analyst. Think of test your application taking future into consideration, how exactly this application is going to be used in near future, and just don't focus on the requirement that is given to you. Yes, there are requirement, that requirement may be correct or incorrect, but try to look out for things beyond that requirement. Okay, so that is what should be the objective of your software testing. Okay, so this was just one example to help you out that, you know, how do we perform testing, just to get you into that mode of software testing. Principle of software testing. You've already started this in our last session, but we are going to start it afresh. Okay. Then after this, we are going to study something about a little bit idea about SDLC. And then once we have studied SDLC, we'll understand what is verification and validation. Okay. And finally, we'll study about severity and priority. So this is the order in which we are going to learn rest of the topics. Now, before I start this topic, I have a question from someone who says that, you know, they want to learn Java on their own. So you know, you just have to wait a little bit till the time I start with learning of this programming language. And the reason is, if you're going to start it on your own, you'll find it a little bit difficult, and this might keep you off track that, you know, we are going to study something that is actually, you know, difficult and not that easy. So and there is so much material available on internet for Java or Selenium or any other programming language, that you tend to get confused. So if you're not following a pattern, if you're not following a sequence of learning, so you won't be finding it that very easy. Second thing is that you need to learn Java, you know, related, you know, a programmer may learn core Java and advanced Java, but for a tester or for a quality analyst, the course is very well defined. You need not learn everything that is there in the Java. So I would just request your people to have a little bit of patience till the time, maybe in next 3-4 classes will be done with the manual testing, and hopefully we'll be switching to uh, learning of Java. So once we are there, we'll go step by step, and we'll learn everything that is important to you for automating your application. So I hope that answers your question. Fine. So now let's continue with this thing that what are principles of software testing. Fine. So as we have discussed on in the last session, there are 7 principles of software testing. Okay, if you can just go through this slide, it shows you the principles of software testing. So software testing is an extremely creative and intellectually challenging task. When testing follows the principles given below, the creative element of the test design and execution rivals any of the preceding software development steps. So this is something uh, we'll understand later. But as of now, what you need to understand is that there are 7 strong principles of software testing. The first one is testing shows the presence of bugs. Second one is exhaustive testing is impossible. Third one is early testing. Fourth one is defect clustering. Fifth one is the pesticide paradox. Sixth one is testing is context dependent. And last one is absence of error fallacy. You need to understand each one of these principles in detail, because you won't be finding, I mean, even though if you're going to search it out on Google, what exactly they mean, they will not make much sense to you. Okay. So it is important that you try to understand you right now, and what in case if you have any confusion, you can ask me right here. Okay. If we move to the next slide, there's no, I mean, you won't be getting any detail about those 7 principles. So the thing is, you need to rely on this recording for understanding the principles of software testing in detail. Okay, now let's talk about the first principle. So the first principle says testing shows presence of bug. What exactly it means? Now, every time you are given an application, what is your intention? You have certain objectives, right? Your objective is to ensure that the software is has captured all the requirements of the application that was given to us by the client. Second thing is to ensure that software is working as per the requirements. Whereas the requirement is being fulfilled by your software, the second intention is the software is working as per the expectations. Now, how you can ensure that your software works as per the expectation? Only when your software is not having any major or critical bugs. Okay, only when your application that you have tested is not containing any major or critical bug, you can say that your software is working as per the expectations. Okay, so the first principle says that testing an application, let me write this down, testing an application can only reveal that one or more bugs exists in the application. So the whole idea of testing the application is to make your application bug free. Okay, so the first principle says that testing an application can only reveal that one or more bugs exists in the application. Now this is what exactly it is trying to convey to us. But what exactly is the objective of this? Okay, what do you actually need to understand by this? Okay, the thing that it tries to convey to us is, therefore, now since we are going to test the application, and the objective of testing the application is to identify defects or identify bugs in our application and get those bugs fixed. Okay, so in a way, indirectly, what this principle is saying, it is saying that it is important to design. Now I have a question. So it says that testing of an application is important because you need to identify more bugs into your application and get them fixed, and once those bugs are not there, so there would be no bugs and the application would be working in accordance with the expectation. Now how you can ensure that more and more bugs could be identified? How you can ensure that more and more bugs can be identified in your application? It depends upon the number of test cases that you are writing. So if there are more number of test cases, that means you have covered more requirement of that particular application. And now when you have covered more requirements, so there are the probability of finding issues increases automatically. Okay, let's say we have studied for login page on that particular day. Had someone written only 2 to 3 test cases for login page, so he or she would not be able to identify much defect, right? Because they are going to execute just 3 test cases for that login pages. But let's say somebody has written close to 15 pages for the login page. So now the probability of finding the bugs increases because now the number of test cases have gone up. So therefore the first principle, what it is trying to convey to us, that it is important to design test cases which finds as many defects as possible. Okay. So this is the objective of testing shows presence of bug. I'm getting few questions over the chat. Let me just check it. So I was saying that what exactly the first principle of software testing is trying to convey to us is that every application consists of bugs, and in order to ensure that your application is working fine, in order to ensure that your application works in accordance with the expectations that it is supposed to do, it is important that you write your test cases in such a way, or you write a good number of test cases so that the probability of identifying bugs increases. So that is the objective of first principle of software testing. Now the second principle of software testing is exhaustive testing is impossible. This is again very interesting thing, and in most of the interview questions you might be asked. Now let's say that, and this is something that we have already have a little bit of discussion in our initial 2 sessions. What do we mean by exhaustive testing? Now when you test an application, it is not, you can never guarantee that now this particular application is not going to contain any single bug. Okay, you can never ensure that, and that was the reason I had always maintained in my sessions that your application should not consist of any serious or blocker bugs. They can contain minor bugs, because as I said that every time you test an application, there are very much chances that some of the trivial cases are missed out. Okay, so and every tester has a different way of testing their application. So maybe the way you test your application may be different from the way any other tester is testing the application. So chances are there, because of the approach every tester applies, it is important, there are very much chances that you might miss on certain trivial issues. So as a result, it is said that you cannot completely test an application and say that your application is bug free. There will always be few minor bugs left here and there. Okay, so that is the reason, and I'll show you, I'll tell you why this. For example, let me just open Paint so that I can show you something. Okay, let's say that you have developed a software application for restaurant billing. Okay, so let's say there is a software application for fine. So there is a software application for restaurant billing. Now let's say in this restaurant billing software application, we are calculating VAT. Okay, we are calculating a tax called VAT. A VAT tax, value added tax. Now, to test this application, you know, there are chances that there'll be hundreds and thousands of customers will be coming to this restaurant. So, and they'll be ordering items of different prices. So based on those prices, you'll have to calculate the VAT. So now if this application is given to you for testing, so you might test it with different data. Maybe you can test it with some data like what exactly is going to be the price. Okay, it could be any kind of tax. Somebody is saying that is this a sales tax, so you can consider any tax. For example, whatever tax whether it's VAT tax or sales tax or some import duty and all. So it's for you to decide whatever tax you want, but it's just a tax. Okay, so now when you have to test the application, you'll have to test it with different data. Maybe you want to test it with $100 or maybe then you'll have to test it for $1,000. Whether on if some customer comes and they order a product, some food stuff for, let's say, $500, so you'll have to test it for different values, right? Or maybe at times it could be in decimal also. The bill could be in decimal also. Let's say like something 105.50 or 40, something like this. Okay, so and there could be multiple such data for which you need to test this an application. Now let's say this is working for fine for $100, this is working fine for $500, or this is working fine for $105 and everything. But you cannot say that you have tested it for all possible data, right? There are so many numbers available. There are infinite numbers, right? So you can never ever say that, okay, I have tested it for all the data, all the possible combinations, right? So as a result, it says that exhaustive testing is impossible. That means you cannot test your application for all the possible test data. That is what the second principle is trying to convey to us. Okay, so what it says is, it says it is not possible to test all possible combinations of data and scenarios. Okay. So it says it is not possible to test all possible combination of data and scenarios. But the challenge is somewhere, we need to define that, okay, we have tested it for, so it says that it is not possible to test all possible combinations of data and scenarios. So if you're testing an application, you cannot test it for all possible combinations of data and scenarios. But somewhere we need to define that, based on which we can say that, yes, at least I'm sure that this application is going to work for this set of data. So for this, in our coming session, we'll learn something that is known as boundary value analysis. So that boundary value analysis method would be used in those scenarios where it is not possible to test your application for all possible set of data. Okay, but as of now, when we're talking of exhaustive testing is impossible, so all it is trying to say is that it is not possible to test all possible combination of data and scenarios. For example, the one that we saw over here. So there could be many possible combination of test data, right, for this restaurant billing application. So we cannot test it for all possible numbers or amounts. Okay, so this is what it is trying to, it says, and what exactly it is trying to convey to us. It says that for this reason, risk and priorities are used to concentrate most important aspect, almost. So your second principle says that you cannot test all the possible combinations of data and scenarios. Fine, I'm okay with that. That I cannot test it for all the possible combination of test data, but I need to test it for certain set of test data. So let's say there are thousands or maybe thousand or more than thousand set of test data available. Okay, so I need to prioritize my things that okay, I'm going to test my application for this particular set of data. I cannot test it for all the thousand set of data, right? Because that is going to be very time consuming and it is going to be very exhaustive. So I'll have to prioritize my things that okay, at least I need to test it. So how I'm going to prioritize, let's say if I have to test it for restaurant billing, so how I can prioritize it? Maybe I can test it for negative numbers. Okay, first of all, I'll test my application for negative numbers. Then maybe I'll test it for 1 digit, digit. Then I can test it for decimal numbers. So this is how you are going to prioritize instead of picking up any random value and feeding it into your restaurant billing software. We'll have to prioritize that. Okay, I'm going to. So the thing is, once you have tested it for any 2 digit number, you can always ensure that for 2 digit number this is going to work fine. Okay, if you have tested it for any decimal value, so you can always ensure that this is going to work fine for decimal values. Okay, instead of testing it for all the available decimal values in the world, you'll have to prioritize your things in this way. And we are going to learn about this approach in detail once we are there on boundary value analysis method. Okay, so that is what boundary value analysis method does. It says that when you have huge combination of test data available, you need to prioritize your test data instead of testing your application for that whole set of test data. Okay, so that is what it is trying to it does. We'll learn about it in detail, but as of now, you need to learn that it is not possible to test your application for all the possible combination of data and scenarios. We need to prioritize our test data in order to concentrate on the most important aspect of tests. So that is what exhaustive testing of second principle, that exhaustive testing is impossible, is trying to convey to us. So the first principle is trying to focus on that you have to write every time you are given an application to test, try to grasp as all the requirement of the application, and based on that requirement try to write as many number of test cases as possible. So when your number of test cases increases, the chances of finding finding the bugs or defects in an application increases. And the more bugs are identified, that means the more bugs would be fixed. As a result, the application would be more stable. So that is all that first principle is trying to convey to us. Second principle is saying that you'll come across situations where there will be many possible number of test data or scenarios available for you to test your application. Now you cannot test your application for all those possible set of combinations. So in order to handle this situation, you need to prioritize your set of test data, that okay, I'm going to test it for this set of data, this set of data, and this set of data. And based on that, we're going to make some assumption that if it is working fine for all the 2-digit number, it will work fine for all the two-digit value. If it is working for decimal values, this is going to work fine for all the decimal values that would be fed in the software. If I'm going to provide some input negative value in my software, so it will not be able to calculate any tax over it. So this is all how we need to prioritize our test data in order to at least convey this, that I'm sure that since this is working fine for this type of test data, it will always work fine for any decimal data or any 2-digit data or 3-digit number when fed in our application. So this is a simple thing that these two testing principles are trying to convey to us. Now the third thing is early testing. The third principle is early testing. Before understanding early testing, I'll give you a little bit of ideas what is SDLC. Remember, we have written it over here, SDLC. So what is SDLC? If I can elaborate this, this is software development life cycle, right? This is software development life cycle. That means every software that is developed has to go to certain well-defined phases. Okay, they have to go through certain well-defined phases. For example, the phases are, if I talk of these phases, so those phases are, the first one is your requirement analysis. The second one is feasibility study. The third one is design phase. The fourth one is coding phase. The fifth one is your testing phase. Sixth one is your deployment phase. The last one is your maintenance phase. Okay. So these are different phases of software. So any software that is developed in the world of software industry has to go through these phases. First of all, you need to know what is the requirement of the software that is to be developed. Okay, so the requirement is given to us by the client, and based on that requirement we do a little bit analysis. Based on that analysis we agree to that, okay, yes, this software could be developed, and whatever requirement is being given by the client could actually be implemented in our software. For example, in our previous session we have seen a login form, right? And on that login form there was username, password, login button and cancel button. So let's say that form is given to us by the client, and the client says that, you know, uh, this is how I want my login page to look like. Now you have the requirement available to you. So based on that requirement you will find, you know, you do requirement analysis whether this requirement is correct or not. Is it at par with the industry standards? So you just go through those requirements. So as we have seen with the login page that there were so many things that were missing in that login page. There was few additional things available on that login page, right? So in requirement analysis you're going to write down all those points, and you're going to you know, go back to the client, and you would have to say over there that, you know, these are the requirements that are missing in your uh, requirement document, or these are the requirements that shouldn't be there as per the industry standards. So this is what we do in requirement analysis. So first and the foremost thing is we get the requirement from the client, and we do analysis of that requirement, whether that requirement is correct or not. Is it incomplete, or is there something that shouldn't ideally be there? That is what we do in requirement analysis. Then there is feasibility study. We'll see all these things again in detail once we are studying about software development lifecycle. Then there is feasibility study, which under feasibility study we see that if the application that is being given to us by the client is feasible in terms of cost, feasible in terms of time. Let's say, you know, he wants to implement some important features or functionalities, but for that you need some high-end softwares which the client is not willing to pay. So you will say that within this defined cost, it is not possible to develop that software. Or let's say, you know, he says that I want the software to be developed, but I want it to be developed within 2 months. And you know that it is not possible to develop such complicated application in 2 months. Okay. So you'll say that your requirement is not feasible in terms of the cost or time that you are mentioning. So that is what we do in feasibility study. Then design is here. Let's say the first two phases pass. Okay, we are okay with the requirement and we are okay with the cost and time. Then it moves to the third phase, which is known as design phase. In design phase, you know, we design so many things, like we design how exactly my application is going to look like. So maybe the designers will give the wireframe structure that, okay, login page is going to look like this, dashboard page is going to look like this. At the same time, we also design the database of that application. Okay, so that is what we do in design phase. Once the design phase is done, we move to coding phase. Now the developers start coding in order to develop that application. Once the application is developed, coding is done, then it moves to the testing phase. Okay, now here we start testing the application. Once we have tested and we have ensured that no bugs exist in our application, then it moves to the deployment phase. That is, it is available on the live environment for end users to use it. And once it is live, it goes into maintenance phase. After every regular interval of time, we just check the basic functionalities of the application, or we upgrade it with new software. So that is how every software has to go through all these 7 phases. And this is probably one of the most important topic of software testing, software development lifecycle. So we'll learn this in detail going forward. Now, having understood a little bit what exactly is software development lifecycle, now let's come to this early testing, the third principle of software testing. Now, what is early testing? Let's say if I say that you have to test, you are part of a testing team, and you have to perform testing. So when exactly you think, out of all these phases, when exactly you think the testing will begin? Now, there is a major myth in software testing field that testing begins only after the coding phase. That means once the application has been developed by the developers, only then you can test the application. That's a myth. And if ever asked, this would be the wrong answer. Okay, so testing never begins. I mean, of course, it begins after, you are doing testing after coding phase, but that's not the starting point of testing. The starting point of testing is from the requirement analysis phase itself. Okay, and I'll show you how. We have already done this. So in our previous session, I have drawn a login page, and I have given that login page for you to identify bugs into it. And most of you identified bugs. You said that forget password link is missing, registration link is missing, and then cancel button shouldn't be there. So in a way, based on the requirement itself, you have identified few issues in the application that is supposed to be developed in near future, right? So that form of testing where the software is not actually developed, but based on the requirement itself, you are able to identify issues, is also a form of testing. Okay, is also a form of testing. So your testing begins in the requirement analysis phase itself. Now let's talk of feasibility study. In the feasibility study, if your application cannot be developed because the cost that the client is willing to pay, or because of the time in which the client wants us to develop the software, that is not feasible for us. So we are also conveying that issue to him. So again, it's a form of testing. So testing starts from the very first phase of software development lifecycle. So you perform testing in requirement analysis phase, you perform testing in feasibility phase, you perform testing in design phase, you perform testing in coding phase. At every phase, testing happens. Now you'll be saying that how this testing that we perform from requirement analysis till coding phase is different from the testing that we are doing over here, right? So it should have been like, if testing is happening over here, we shouldn't have defined it separately after coding phase. So how is the testing that we are performing here different from testing that we are performing here? So how it is different? Now, till here your application is not developed, right? Till here your application is not developed. It's still developing, right? So the testing that you perform before your application is actually developed is known as verification. You see this word verification? Okay, so verification means till here you are performing verification type of testing. Okay, what is verification? Verification means, if I talk of verification in detail, so let me just define it over here. Verification, if you just Google it, you'll find a definition. Are we building? We have requirement document available, we have design document available, we have coding documents available. So based on those documents, what we do, we try to figure out that are we actually building the right product? Are our requirement in place? For example, in our previous session, we have seen the requirement of a login page. So we perform testing based on the requirement document. Okay, so that type of testing which is done before the product is actually developed is known as your verification. So till here, this type of testing is known as verification. You don't have the actual product available to you. You don't have the actual software available to you. You just have the requirement. You have the design requirement. You have the functionality requirement of the application. So based on those documents, you do analysis. You have walkthroughs. You have inspections of those documents, and based on those documents, you try to find that everything that is written in this document is fine or not. Are we missing out on anything? Okay, so that is the reason we say that testing begins from the very first phase of software development life cycle. Okay, so that is what the early testing is trying to say to us. Okay, early testing ensures that based on the document available to us, we check if the design is correct, we check if the requirement is correct, we check if the documentation is correct, we check if the requirement is feasible or not. So all those things we do in early testing. Okay, so with early testing, we have understood two important things. First of all, the testing begins from the very first phase of software development life cycle. It is not important, it is not necessary that you have the actual software available to test the application. Okay, you can always test it beforehand. It's as simple as that. You go to market in order to buy a product, and before buying a product, you just go through the requirement that is written for that particular product. You read it, and then you see that, okay, is this in accordance with what actually I wanted? So, while you are inspecting it, while you are having a walkthrough of the description of that particular product, so that is kind of verification that you are doing, right? And after you buy it, you come back to your home and you start using that product. So now you are actually validating that whatever requirement was written on that particular for that particular product is actually working or not. Okay, so till here the software is not developed. Okay, and any testing that we perform before the software is actually developed is known as your verification. Okay, and the testing that we perform from here till here, that means the last maintenance phase, is now the software is actually developed. So you are performing testing on the actual developed product. So that is known as validation. Okay, so what is validation? So verification is, are we building the right product? And validation is if the right product is built or not. Okay. So these are two things, and verification is performed. We can also write, we'll again see this in detail, that what are differences between verification and validation, but this is the basic one. So in verification, we are actually testing, are we building the right product? And in validation, we are just validating if the right product is built or not. That means whatever product we have created, is it developed in accordance with the requirement or not? Is it developed in accordance with what the client actually wanted or not? Okay, so that is the difference between the testing that we perform till here and the testing that we perform in this testing phase and rest of the phases. Okay, any confusion till here? Okay, so what do we do in early testing? So let me write it out. So we check whether if the requirement is correct and at par with market standard. The second way is we will check if the design is correct. Third thing is we check if the requirement is feasible or not. When we talk of feasibility, it is in terms of cost and time. At times also because of resources. Maybe only experienced people can develop that software, and that sort of resource pool is not available with us right now. So it could also be reason for not being able to develop the software. Okay, so these are a few of the things that we do in early testing. So the overall objective of early testing is that your testing should begin as soon as possible. Okay, so what exactly it tries to say is that testing should begin from requirement analysis phase. So that is what early testing is trying to convey to us. Fine. Now the fourth principle says defect clustering. Okay. Now defect clustering is actually kind of analysis that has been performed all over the world in the field of software testing. And based on that analysis, we have come up with certain principle which is known as defect clustering. Now, what was that analysis? The analysis was that most of the reported defects are related to small number of modules in a system. Write the definition first and then we'll explain it. That is, small number of modules contains most of the defects in the system. Okay, now what exactly it means? Let's say that your application, the application that you are testing has few pages. For example, it will be having your login page, it can have your home page, it can have your dashboard page, it can have your contact us page. Okay, all these pages, let's say it has got these 4 pages. Now all these 4 pages would be tested. Okay, so let's say for login page you have written close to 20 test cases, right? For home page you have written close to 30 test cases. Okay, for dashboard you have written approximately, let's say, 45 test cases, and for contact us again you have written some 10 test cases. Okay, for testing this. So you have written these many test cases for testing this application. Now while you will be executing these test cases on the actual software, let's say on login page you have identified somewhere like 2 bugs. On home page you have identified somewhere like, let's say, 9 bugs. And on dashboard page you have identified somewhere like 20 bugs. And on contact us page you have identified somewhere like 1 bug. So what this defect clustering says that, when the application all over the world were tested and an analysis was done, they identified that most of the bugs reported are not evenly distributed. It is not that all modules will carry will have almost equal number of bugs. Okay, it's not evenly distributed. So how it is distributed, it was observed that in all the application, and this is something you'll always also realize once you're testing the application, that the bugs are not evenly identified in all the modules. There will be certain modules which will always have higher number of bugs when compared to rest of the modules. So that is what your defect clustering says, that your defect is clustered around a small number of modules instead of being evenly distributed. Is that clear? So this is a kind of analysis. This principle is a kind of analysis which says that most of the reported defects are related to a small number of modules within a system. They are not evenly distributed. As we can see over here, the dashboard, if I call focus on this dashboard, so this has got major number of bugs, and then we have another module which has got major number of bugs. So this is how, while you are actually testing the application, you will see that if you have identified 20 bugs, So those 20 bugs will not be like, 4 bugs from one module, 4 bugs from another module, and so on. It would be like maybe if you are testing 5 modules, so maybe 3 modules will have just 1 or 2 bugs, whereas remaining 2 modules will have like 15 bugs. So that is how you identify, this principle works, or this is how they have come up with this principle based on the analysis. Okay, so that is what defect clustering says, that you find major chunk of bugs in a specific module rather than it being evenly distributed. Okay, so in a way, this is also, this also follows a principle that is known as Pareto principle of software testing. Okay, what it says, approximately 80% of the problems are found in 20% of modules. Okay, so this is what the defect clustering principle is all about. Okay, it's kind of analysis. Based on that analysis, we say that the defects are not evenly distributed. I can write this also. The defects identified are not evenly distributed. Now let's talk about the next principle, the fifth one. Okay, so the fifth principle is the pesticide paradox. Okay, now what is pesticide paradox? So let's understand what is pesticide actually. Pesticides are used to kill bugs in farming industry. Okay, then what is pesticide paradox? Now pesticide paradox is, if you keep on using the same set of pesticides again and again every year, the effect of that pesticide on the bugs decreases. They are no longer effective on those bugs as they were in previous year, because with every passing year the bugs develop that endurance against that particular pesticide. So in long run those pesticides are no more effective. Okay, same is the case with software industry testing as well. What exactly it means? It means that if you, let's say, I believe WhatsApp came into existence around 2009, if I'm not wrong. Okay, 2009-10. Oh, okay. So when it came into existence, there would have been certain set of test data written, right? Let's say if I talk of it came into existence in 2009, and then we have written certain set of data test cases, right? Let's say at that point of time, we wrote around, this application was given to me for testing, and I wrote around, let's say, some 1500 test cases to test WhatsApp application in 2009. Now, from 2009 till 2020, right, the application has upgraded. So many new features have been implemented, so many changes have been made, and it has been constantly upgraded, right? But if I keep on using the same set of test data that I have written in 2009, will I be able to identify any more bugs? No, because I have not upgraded my software in accordance with the change in the WhatsApp application. So that is what is pesticide paradox, right? So if you keep on running the same set of tests over and over again, chances are no more new defects will be discovered by those test cases. Okay, so what exactly it says? So the pesticide paradox says that if you keep running the same set of test cases over and over again, chances are no more new defects will be discovered by those test cases. That means that's exactly what the pesticide paradox is all about. If you keep on using the same set of pesticides over and over again for consecutive years, there are chances that that particular pesticide will no longer be effective on those bugs. Same is the case with software testing field also, that if you keep on using the same set of test data that you were using for testing the WhatsApp application in 2009 till 2020, there are very much chances that you won't be able to find new bugs in the application based on those set of test data, right? So what exactly it means? It means that you constantly need to upgrade your test cases, right? Okay, you constantly need to upgrade your test cases. Fine. How we can handle this? So what exactly it tries to convey to us? It tries to convey, so that first you update your test cases as per the change in requirement. Okay, and accordingly you need to change your data set as well. What exactly the second point means? Change your data set. So in 2009, as far as I remember, we were not able to see any audio visual. We were not able to send audio video to from one person to another person, right? We were merely able to send text. So now earlier our set of test data that we use for testing the application was text, but going forward now it is, you can share your images, you can share audio, you can share your videos. So now your test data has also changed. So with the changing requirement, you need to update your test cases accordingly, and also you need to change the set of your you need to change your data set. Okay. So are we clear about what exactly is pesticide paradox? It just tries to convey to us that with changing requirement, you need to upgrade your test cases as well. You need to upgrade your test cases and you need to upgrade your test data. This is all that pesticide paradox tries to convey to us. And if you're not doing it, you won't be able to identify new bugs in your application. That means you're going ahead with an application which consists of bugs. So that is a major flaw in your software. Okay. Now let's talk about the sixth principle. The sixth principle says that texting is context dependent. Says that testing is context dependent. Now let's say that there are two applications, right? There are two different applications. There is one application which is from medical domain, and then there is another application which is from gaming domain. And there are two applications from two different domains. One is from medical domain and second is from gaming domain. Now, what this principle testing is context dependent says? It says that the test cases of one domain, okay, the test cases of one domain cannot be used for testing another domain. Okay, because your testing is context dependent. Both of them are completely different application. As a result, you cannot reuse the test cases of medical domain into gaming domain. Because medical domain software testing has to be very precise and accurate. Whereas if we talk of gaming domain, the testing is altogether different. It has to be tested if it is compatible with your hardware, or if you need any particular RAM in order to support that particular game. And there are various other things that we need to consider in gaming domain testing, whereas they are not applicable for medical domain, right? So that is the simple thing that testing is context dependent trying to convey to us, that you cannot use the test cases of a particular domain into some other domain because they are just not feasible into each other. Okay, It's the only thing that it is trying to say to us. Fine. And then we have a last principle, which says that absence of error fallacy. Okay. So what is absence of error fallacy? Anytime you come across a situation where you say that I'm no longer able to identify bugs in my application, okay, then you need to actually revisit 4 different things, or maybe 2 to 3 different things before saying this. If you ever come across a situation where you are saying that, I'm no longer able to identify bugs in our application, okay, so somewhere, there could be a possible reason for not being able to identify bugs. Okay, the first reason could be, if I talk of first reason, it could be you have not upgraded your test case. You need to upgrade your test cases, as we see in the previous case where we are not upgrading our test case for WhatsApp application. So definitely we are not going to identify any bugs into it. So just because you're not able to identify bugs, you cannot say that the application was working fine. The problem was you have never upgraded your test cases. So you need to upgrade your test cases. Okay. The second thing is you need to revisit the software requirement. Okay. The reason is you're not completely aware of the software requirement. As a result, since you're not aware of the software requirement, you're not able to write the complete test cases. Since you have not written the complete set of test cases, you're not able to identify bugs. As a result, you need to revisit the software requirement. Okay. And the third thing could be configurational environmental challenges. At times while you're testing the application, you'll notice that your application is working fine, maybe on Windows, but it doesn't work fine on Mac, right? Or it is working fine on Mac, but it is not working fine on Linux. Okay, so there are also environmental challenges. Okay, now this is again requirement specific. If your client says that I want to test my application on different operating system, you will test it. Otherwise, you won't do it. Also, you'll find that sometimes the application works fine on Internet Explorer, but it is not working fine on Mozilla Firefox browser, or it is working fine on Firefox browser, but it is not working fine on Chrome browser. Okay, so we all need to, depending upon the requirement, we all need to keep these parameters into consideration. Okay, for example, till now we were testing the application, but have we thought of environmental challenges? Have we thought of browser challenges, that this might work on this particular browser, this might not work on this particular browser? And that was the reason I have already mentioned that it is not possible to identify all the bugs in an application. Maybe you tested it for Chrome browser and everything was working fine, but it went to the client and they have tested it on Mozilla, and they said that this functionality is not working fine, or your UI is not displayed, your interface is not being displayed properly. Okay, so all these things, we'll see how we can manage them, because this is so wide field. You have to take everything into consideration. Let's say your application was working fine on all the browsers and on all the operating system, but and you said that every feature and functionality is 100% working fine, but you must have seen that at times your application crashes or your application is extremely slow. So somewhere you have not tested the performance of the application. Okay, so all these things, what we need to capture, what we need to leave, is something that is well defined in requirement analysis phase. And maybe going forward, I'll also show you a requirement document of real product that I have worked on. Okay, so that you get an idea that what exactly are the things that there are in requirement analysis or requirement document, and based on that requirement document, we have to move ahead. Okay, so that is all about the 7 principles of software testing. And apart from this, we have also understood what is verification and validation, right? So verification is something that we do before the software is actually developed, and validation is something that we do after the software is developed. That means we are actually testing the real product. Whereas in verification, we are actually testing the virtual product. The product is not yet developed, but we are identifying issues into it based on the requirement document and design document. Whereas in validation, we are actually testing the application, and we are just ensuring that whatever things we have verified in verification phase are actually implemented here in validation phase. Okay, and then we have a little bit of idea of software development life cycle. Fine. The only thing that is remaining is severity and priority. So we'll pick this up in our next session.
Jan Bass Training. Learn and grow.